Analytics is hard. If it wasn't, right, everybody would be doing it. But you hear about constantly from people, I want to know what my data is telling me. I need to visualize my data. It's not easy to do. To get up to the top, it's very hard, right? When you look at the bottom quadrant here, when we're just talking about descriptive and diagnostic, you often go through iterations with this cycle. Getting data from one system, two systems, pulling data out, learning from it, difficult. When you start integrating dozens of systems where the data is different, it doesn't have the same format, it doesn't have the same story to tell, it gets very difficult. So you often find yourself iterating through this bottom piece of this maturity model. Why do we want to move up to the top? Well, there's multiple reasons. All the dashboards we showed you are very important, but they're reactive, right? You talk to people and you say, analytics can tell you what's going on today, look at trends, what's going on in the future. An hour from now, if I give you that data, the state of your operations may have changed within an hour. If somebody has to go and manually look at that data, the decision you've decided to make at that point may not be worthwhile anymore. So by moving up this curve, we're trying to predict what's going to happen so that you can make those decisions very early on and not reactionary. One of the hard things about this is actually getting data. So you'll start hearing things like data lakes. Data lakes are simply a way for us to take all the data we know we have available and throwing it somewhere. We don't know what we want to do with it yet, but let's just put it somewhere, and then we'll figure out what we're going to do with it. Cleansing that data is when you start getting into things like data warehouses, data marts. We're now putting business knowledge on top of the data, structuring the data, maybe transforming the data to prepare it to move up this curve. It's not easy. So, how do we get to the point where we're being proactive? Predictive and prescriptive analytics. Through machine learning, artificial intelligence, data science, that's how we get there. Those are all buzzwords, and it's a magic 8-ball. We'll see here that it's a process. Machine learning is a process. The people aspect doesn't get taken out of it. We're still very important. We don't just hand over everything to a computer and say, figure it out for me. It's a process that we're involved in. So, what we want to do is we want to take machine learning algorithms, apply it to all that data that we've ingested into the system, and start being able to make these predictions. These models that we build aren't generic models, though. You do have to have a business case in mind. The models are targeted at problems, right? So if you don't understand what you're trying to predict, you don't understand the business problems you're trying to solve, you can't build a model. There's no one model that fits everything. And that's where data scientists and the people that are familiar with the business are hugely important. They define what's important. The computer only can learn from what we tell it. It doesn't go off and do it itself. So the years of knowledge that we've built up of our operations, that's what helps drive these models to allow us to do these predictions. The biggest benefit of this is that it's constantly adapting and learning from the data. As the business continues every day, day in and day out, all of that data is going back into the model and we're learning from it, right? What we learn today is going to be different than what's happening a week from now. But somebody's not going in there and figuring it out themselves. The model is trained to constantly take that data and adapt to what it learns, right? Seasonality will be learned through the model over time. Historically, we know engineered standards. That's what we've used to help measure performance, productivity. Very good, very reliable, but they're costly. And if you change your operations, you change the layout of a warehouse, you change your product mix, you move into e-commerce, what happens? Your engineered standards are out of date. And now you have to go and redo them, and that's more money. The idea with machine learning is it's going to learn those changes that are happening in the operations automatically, as long as your model's correct. And the model's going to be correct if we get correct information and we build it properly. Some of the things that we've started looking at is using machine learning and analytics and applying it to, again, we need business cases, dynamic slotting and workforce planning and management. Everybody understand what I mean by dynamic slotting in a warehouse, right? So where do we place products so that we can increase efficiencies of picking, put away, replenishment? Machine learning can help us solve that problem. It's a difficult problem to solve. So this is highlighting the fact that machine learning is a process. It's not that magic 8-ball. The machine learning piece is just that little algorithm square, right? That's how do we train this model? What's it trying to model? What's the business case or use case is trying to model? This is where all the neat, nifty technology is going on. This is where our data scientists are doing their work and trying to figure out how to make sense of the data. But number one is you need the data. Most often you start with historical data. We have it, it's part of the systems that we have today. We have access to it, we can feed it into the algorithm, gets fed to the predictive model, we get a prediction out of it. We can then look at that prediction and see if it was accurate. Based off the results, that data gets fed back into the model. We're constantly learning from that. The interesting part here is the current data. So there's some diminishing returns. We can feed as much data as we want into these models. But there's a point at which the effort to get that data, make sense of it, and put it into the model starts to go down. So if you take a problem like slotting, dynamic slotting, historical data can show you over the last 6 months what are my high velocity products, what are the slow moving, and we can make decisions about where to slot those products based off of that. But think about it, last 6 months doesn't guarantee the next 6 months, right? Maybe I don't have any orders coming in for a product that was the top product the last 6 months. If I'm just using historical data, I may go and tell you to slot this product somewhere else, and now it's never going to get touched. Its position's been optimized, but I don't have any orders for it. By allowing the injection of current data, now you can make better decisions. So if now I take sales forecasts or some sort of planning information, that can be fed into the model, and my optimizations can be tweaked based off of future information. The important part is that, again, there's going to be diminishing returns to trying to get that data into the system. So any of these platforms that are built on machine learning, if it's not taking the data in automatically and learning from it, it has to provide the ability for you to inject knowledge. Yes, here's the optimization you've given me over the last year, but based off of my business that things are changing. Something like slotting, you may look at current events, you may look at weather, the makeup of the workforce. That's all information that can change the decisions from a model. So again, we either learn from that data and we try to inject it into the system automatically, or we allow for that data to be brought in as part of what-if scenarios. That's a big part of this. We're going to present optimizations to folks based off of what we learned, but then we want to give you levers that can say, well, what if this changes over the next months? What if I want to prioritize replenishment over picking? What if I'm worried about safety and congestion in the warehouse? Play what-if scenarios, have the model regenerate optimization. So why? Because it's got the data. It knows how to model it, you weight it, and it can give you different results as a result of that. This just reiterates what I talked about a little bit. Historically, engineered standards, very good. We've relied on them for a long time. We think machine learning presents a different approach here that can give us, if not equal, but better results for a much lower cost. Engineered standards, very manual, static, very costly, and they're reactive. Every time we change something in our operations, we have to go and have new standards created. With machine learning, the model is doing that for us. As long as we keep feeding it data, the daily course of operations is going to keep sending data into that model, and it's going to keep getting smarter and learn and give us better optimizations based off of the current state. And again, not a month from now, that's going to tell us a month prior what to expect a month from now, so that we can be proactive. Why predictive analytics? If we can be proactive, right, we stop problems, or we find problems before they occur. We can adapt to differences across sites. We can see why one site's not performing against another one and try to make changes as a result. If you put it in the context, think about productivity. So another use case we talked about was workforce planning. So we're looking at the productivity of workers. We're looking at whether or not we can finish an order on time to put onto a truck. So we're trying to predict what we have to do in terms of workforce to get them in the right position so we can guarantee orders are going out. By being proactive, in trying to figure out what's happening a month from now, you can take workers who maybe are not being productive. Maybe it's not their fault, right? Maybe products are slotted incorrectly. Maybe did I go out? Can you hear me? And if somebody up here doesn't have the visibility to that data, the workers are going to feel defeated, right?
So if we can predict where products need to be slotted, if we can predict the right level of workforce for the season coming up, we're setting up the workers to be more productive. We're setting them up to be happier, right? Happy worker, more productive, better for business, better for customers. It's all connected. But you can't do that retroactively, right? We have to be proactive with this. Machine learning allows us to do it. Lastly, the costs are reasonable because we're not going out and redoing the standards every time. We've built the model, the data's there. Once you build those pipelines to get the data into the system, it just works. Will you have to tweak it here and there? Sure, but that's built into the system to allow you to do that.